for being everyone. I'm going to talk about the UberCloud HPC Experiment. A part of my talk, we'll hear from Frank Ding, who's the Technical Computing Manager at Simpson Strong Tie. He had one of the HPC experiments in the past year, so we'll get to hear from him as well. So everyone in this room knows HPC is required to stay competitive, especially if you think about the manufacturing sector where they need to develop new products. And the engineer usually has three ways to go. He could either get a beefier machine and practice high-performance computing to some level on his workstation, or he could get access to a corporate cluster. Or the third option nowadays, we heard from the previous speaker as well, is going to the cloud, at least for some of your workloads. So there are pros and cons in each of these areas. Obviously, workstations do come with some severe capacity limitations. Usually they are relatively slow, so engineers may need to reduce the complexity of their physical models. Or if they're running parameter studies, they limit the number of parameters they run against. The problem that comes with the other option, which was the local cluster option, is usually the cost. Deploying a cluster, especially for the small and medium enterprises, tends to be outside of their budget. And the chart you are looking up there talks about the cost of hardware versus everything else that comes into play when you look at the total cost of ownership. And an IDC study a couple of years ago was showing, if you have a modest scale HPC system under $100,000, your cost over a 3-year period could be, beyond $1 million. So then the alternative about HPC in the cloud, HPC as a service, becomes an option. And there are obviously pros and cons to that as well, just like with the other options. First and foremost, it's a brand new, service model, and there are challenges around discovering what comes with that new service model, such as security, privacy, so on and so forth. So we turn around and ask our users in our community, in the UberCloud community, and they tell us things like, software licenses sometimes get in the way. They tell us large file transfers are sometimes an issue. And what we have done is we have built what we refer to as the HPC Experiment. At the HPC Experiment, we bring the end users their specific problems into the experiment, and we let them try for free the end-to-end process of going to the cloud. So we're basically giving the opportunity to the end user community to try how to use HPC in the cloud. So the benefits of doing something like an HPC experiment from an end user perspective are quite obvious. First of all, the experiment is free. We provide the compute resources, the software licenses, and in some cases the expertise to go to the cloud for free. And they don't need to necessarily hunt for the providers who would give them the free trial options. If you went out there, you probably could find deals around 30-day trial, come in, test our capabilities, but you wouldn't necessarily know which one to start with. So HPC Experiment gives you a leg up there, and we also bring a step-by-step process which the end users can follow, and go from no usage to discovering how to use the cloud. The end-to-end process that we have built for HPC Experiment is available in an online tool. So when we bring the resource provider, the engineer, and the consultants all together, they have a place to share all of the information that the team is producing. So last year I was here talking about the HPC Experiment, and when I just looked back, I see quite a bit of progress. Currently we have over 1,000 participating organizations and individuals. This is from 4 groups: end users, software providers, resource providers, and experts. And we somehow got into 70 countries. We decided we would start specifically in California, but before we knew it, people from everywhere were signing up. So now we're in 70 countries. We have done over 125 projects, and with round 5, when I talk about a round, these are 3 or 4 month cycles that we work together with our teams. We're just starting number 5, so we'll probably end up with another 40, 50 teams very quickly here. We have also achieved a mechanism where we can keep HPC Experiment free for the participants. Obviously, somebody has to pay for the lights to stay on. And thanks to our sponsors, Intel, IDC, Ball, and Autodesk, we have been able to achieve the sustainability of HPC Experiment as well. So when we look at what UberCloud does, we see it in 3 levels. We, first of all, need to achieve that the community has a place to go so they can discover if HPC in the cloud is the right option for them. So we have developed a community platform, which I will talk about briefly. UberCloud HPC Experiment is the second layer, and that's what I've been talking about. That's our free trial capability. And we have very recently launched the UberCloud Marketplace. So the UberCloud community is at theubercloud.com. That's where we bring all of the community members together. You could go there and take a look at the projects that have been completed. You can look at what type of challenges they ran into and how they resolved them. And through our forums on theubercloud.com, you can also interact with the team players who are putting those use cases together. In the UberCloud Marketplace, which just recently got introduced, we have developed a method for the, let's say, graduates of HPC Experiment to go ahead and start purchasing the computing power that they require in the cloud. So the opportunity here is just by entering a few pieces of information, we can provide competing quotes from many players, and the end user gets the opportunity to pick and choose from a pre-selected, pre-qualified list of vendors. So, as I was saying, today with me is Frank Ding. Frank worked on one of our HPC Experiment projects last year. So, Frank?
Good afternoon, everybody. And I joined as an end user for this UberCloud HPC Experiment. And you can see in our team we have ISV involved, which is Muna, and also cloud service provider, Nimbix, and also have a domain HPC domain expert, and also third-party software for remote visualization, and also and the mentors. A little bit about our company, and we are a structure building system manufacturer. Essentially, it's a building component and serving the light frame, which is mainly residential construction. So for our case, we make structure connectors, fasteners, fastening systems, and lateral system, moment frame, special moment frames, anchoring systems, and FRP repair and protection strengthening for infrastructure. So you can see it's a very traditional manufacturing company, but we use HPC for our product development process because there's a lot of failure and a lot of damage involved when we do this simulation for structure simulation. So, and sometimes multi-physics involved. So for high fidelity simulation, so you need HPC. So we started actually, first generation is 2005, we bought our first HPC clusters, and currently we have, this is second generation cluster, which is just a very small scale, and just 4 node 32 core systems, and this is already 4 years old. And so, well, back a little bit. So the motivation for joining this UberCloud experiment is we have a fixed capacity in-house. So sometimes we run into problems. The job is too large or maybe taking too long using our existing system. So for surge of capacity, so we need to have a solution available for us to tackle jobs that is bigger, so beyond our in-house capabilities. So that's why, and the UberCloud experiment provide a very good platform for us to do this kind of hands-on experience to identify some of the problem issues along this way. So this is just the cloud-based HPC workflow. So pre-processing, which you prepare the modeling and prepare the Abacus input deck, was done locally, and then input deck was transferred to the data staging area in the cloud through the secure FTP. Then just Abacus job was submitted to the compute cloud through the Nimbus web portal. So, and the job monitoring and come with that. So you can see some dashboards over there for the Nimbus dashboard. And after the job is done, the notification is through email or job status dashboard. You can see that. And also the post-processing. And yeah, we would like to do that locally because it's very interactive. So for good end-user experiences, it's preferred to do locally. But for the job size for this one is particularly on the right-hand corner over there. So this is just anchor system. So the job data sets, the results file is like 3 gigabytes. So transferring the large amount of data through the internet back to the local desktop takes like 2 hours. So it's way too long for us to. So it's impossible. So that's why we look at the other solutions like a remote visualization to solve this problem. So this is just the job benchmark. So using in-house system, we need a 12.5 hour to solve this problem. But with cloud resources, we can run like 72 cores, right? With Nimbus current system. So that's just reduced to 5.5 hours. So you can see the time reduction to compute these jobs. So again, back to that, because the results files are too large, and so it take a long time to download back to the local desktop for post-processing. So that's why we look at other solutions. So this one's actually the focus of this experiment. So using DCV from Nice Software, which is a desktop cloud visualization software, which is running this visualization on the remote servers, and only the image is sent back to the local desktop. So running the visualization remotely. So we created a little testing matrix for how friendly, how usable this approach will be. So, and we found that there's some glitches, but most of the time it's okay. But some of the functionalities is not possible with that current software. So like this one, copy and paste contour plots, which we use quite a bit, and so it's not working through remote visualization. So this one is definitely the things we want to solve if we go like remote visualization. And another aspect is dynamic manipulation of this graphics. The response depends on the connection, end-to-end connection, internet connection. So sometimes the response is not that smooth. So because we found out we're testing the internet connection speed and bandwidth, sometimes we have 20 megabyte pipes, but it's shared by many applications and software in our company. So it's kind of a bottleneck for this one. So sometimes it's not a good user experience when you do the dynamic rotation, zooming, zoom out. So the data movement, it seems like, it's the bandwidth issues and also the remote visualization we used. So we revert to a remote visualization. This is just one part of the equation. The other part of the equation is the software license. So for this case, because we joined this experiment, so ISV provide free license because, well, even for now, they don't have really published a licensing for cloud licensing model, so they don't have it. So that's another big issue need to be resolved. So we can see the benefit of doing this exercise, and we can see that UberCloud brought all those parties involved because this application involves so many different parties, the ISV, the cloud infrastructure service provider, and also third-party software provider and the user application. So, and it's good we have this platform to do this kind of hands-on experiment. So the lesson learned is, it's just data movement and internet connection bandwidth is just the variability. So it depends on maybe some company. I know that some company doing this test, they didn't encounter this kind of they didn't encounter this kind of a bandwidth is not a big issue for them, but for us that's a big issue. So we also identify some of the workflow problems. So like some of the feature won't work through the remote visualization. So. So overall, it's a very good experience doing this experience. So we can identify some of the issues and bottlenecks, and so we can have a good feeling. So next time we're looking for a new solution, so we have an idea what we're looking for. So I think that's it. Thanks.
I'll leave just a few minutes for question answers at the end. If you want to look at the project write-up that Frank has, including 24 others, you can download the UberCloud Compendium. It's fairly easy to find on the web. If you can't find me, just give me your business card, and I will definitely send you a copy. And we're looking for more participants. We would look forward to all of you guys joining as well, either as active participants who are doing HPC experiments, or as observers who are taking a look at projects like the project Frank talked about. Are there any questions for either me or Frank? Please. The question was, what are the license models of the ISVs we are working with? You would be surprised. Just about every ISV is out there and trying to figure out what type of licensing model they will introduce. And we do also see a few of them already are leading the way. So in terms of the HPC experiment, the licensing model is very simple. We ask them to donate the licenses for projects like Frank's. So you don't have to worry about the licensing model. And by building a community like this, we want to show that to the providers, to the ISVs, that there is a market here, and they should figure out what their licensing model needs to be. So it is a catch-22 that we are trying to break. We are going to see more and more licensing models probably get introduced this year. We have heard from just about every large CAE vendor out there that they are definitely thinking about introducing a licensing model for the cloud. There's not going to be one answer. They are all going to do it in different ways. We hear some of them are doing it on clock time, for example, as many cores as you want. Some of them are going with CPU core hours. Some of them are going with what they refer to as PAC type of licenses, which give you up to a certain number of cores. So they will all have their own unique tweaks in how they do licensing. Yes, please. Good question. So the question is, are we testing different types of hardware in the HPC experiment? There are 50 resource providers who are participating in HPC experiment. So we do have a large variety of hardware in there. I know you're probably looking for specific, networking equipment like InfiniBand, etc. Yes, they are available. GPUs are available, GPUs in some providers. So yes, we do have the variability that you're looking for.